Minasan, konnichiwa. Good afternoon, everyone. My name's Nicole Fasana, and I'm the Investment and Trade Commissioner for Northeast Asia in Western Australia. I'll be your MC this afternoon. Before we begin, in Western Australia, it's customary to acknowledge and pay respect to the traditional custodians of the land on which we meet. Although I am in Japan, as we are welcoming people from across Australia, I'd like to pay my respects to elders past, present, and emerging on whatever country you may be joining us from today. I welcome you all to the fourth Nichi-Go Global Jaybridge webinar as we gather, discuss, and explore new opportunities on green energy and battery technology in Australia. The Nichi-Go Global and Jaybridge webinar series is an initiative of 5 Australian state governments, Japan External Trade Organization, JETRO, and the Consulate General of Japan in Sydney. It's supported by the Australian-Japan Business Cooperation Committee, Innovation Dojo, and the Consulate General of Japan in Perth. The webinar series is designed to highlight the potential of innovative Australian companies to forward-thinking Japanese corporations. The aim is to add value through Japan-Australia synergy, and the Australian companies we select are pre-screened for viability. Western Australia is thrilled to be hosting the 4th event in this series, following the first 3 webinars which were delivered by Victoria, New South Wales, and Queensland. While the global landscape has shifted in the last 2 years, the pandemic has presented Australia and Western Australia with some unique opportunities. There is huge potential now for Japan and Australia to work closer than ever before. It's my pleasure as part of Invest and Trade Western Australia to host today's webinar that will highlight the opportunities in clean energy and battery technology nationwide, showcasing one high potential company from each participating state. We have a great lineup of speakers today who are all happy to share their knowledge and insights regarding today's topics. If you have any questions for the speakers, please submit them to JETRO. Takahara-san from JETRO will provide instructions at the end of the seminar. Without any further delay, let me introduce our first speaker for today, Mr. Ben Laidler, Director, Battery and Critical Minerals Industries of the Department of Jobs, Tourism, Science and Innovation, providing an overview of clean energy and battery technology opportunities in Western Australia and Australia. Thank you very much.
Hi, Ben. Maybe because of your network program, we cannot hear what you say. Your microphone is actually on, but we cannot hear you.
Takahara-san, can you hear me now?
I can hear you. I can hear you. Thank you very much.
Apologies. Sorry for that. Can you see my screen, Takahara-san?
Yes, I can see your screen. Thank you.
Okay. Apologies. So I'll start from the beginning. So thanks for the introduction. I was going to provide a overview of Western Australia and some of the exciting opportunities that battery and critical mineral industries present to investors. And so the best place to start is in the upstream in some of the mining opportunities. So WA has a huge endowment of a diverse range of critical minerals and has long held a reputation as being a global leader in the resource sector. So most notably, this has been in commodities like iron ore and LNG, where West Australia has welcomed significant Japanese investment. But increasingly, this is moving into clean tech metals. So for example, West Australia supplies around half the world's lithium and is a major producer of nickel, manganese, cobalt, which are all used in the production of rechargeable batteries. WA is also a major producer of rare earths, which are used to manufacture permanent magnets that have applications in electric motors, wind turbines, and defense technologies. We also have significant high quality resources in vanadium, platinum group elements, which are quite rare around the world, and we found some significant discoveries quite recently, as well as copper and many more. There's a lot of upside potential to this resource reserves position. Nearly 6 times the size of Japan, West Australia has a large landmass, and despite decades of mining and exploration activity, a lot of that area still remains underexplored. It's also worth noting that historical exploration wasn't typically looking for what we now call critical minerals. And there are positive signs for reserves upside in some of these previously explored areas. And a good example is there's a lot of gold mining companies in Western Australia that have gone back to old core samples, have found significant reserves of lithium, and it simply wasn't something that they previously assessed for. We're also seeing material opportunities through the mining of tailings, which is exciting from both the industry development, but also a circular economy perspective. And a great example is a company called Aluka Resources, who are proposing to develop a large-scale rare earths refinery in Western Australia using byproduct from their mineral sands operations. However, our story is more than just mining, and it's the role of my team to increase value-adding activities in Western Australia and move our local industry downstream. The opportunity is huge and the timing is right now. So as industry leaders, governments around the world rapidly move to secure and diversify their supply chains, you just need to look to the US and the EU and some of their recent announcements. There is a clear drive by major consumers to mix up existing traditional supply chains. In recognition of this opportunity, WA has a dedicated battery and critical mineral strategy, and this forms a key pillar of the government's economic diversification agenda. So at its core, the strategy aims to bring 2 opportunities to fruition. That is, transform Western Australia's world-leading mining sector into a mineral processing and chemical manufacturing hub for battery and critical minerals. And we're well on our way to bringing that to fruition. And then from there, establish a globally significant battery manufacturing and recycling industry in the state. And that's something that the West Australian and Australian governments are investigating quite seriously. So nearly 4 years on from the launch of the strategy and billions of dollars of private sector investment, West Australia is well on its way to establishing itself as a destination of choice for midstream processing activities, with the next step being things like cell manufacturing. And to draw out some of these recent midstream investments, some of the world's largest lithium producers have decided to locate in Western Australia, including Tianqi from China, Albemarle from the US, and SQM from Chile, all of which have partnered with local West Australian companies to bring their plans to fruition. Tianqi and IGO produced Australia's first commercial quantities of battery-grade lithium hydroxide in May this year. Albemarle and Mineral Resources were soon to follow, with production from train 1 of their Kemerton lithium hydroxide plant in July. And then there's Covalent, a joint venture between Wesfarmers and SQM, which is rapidly moving to build WA's next lithium hydroxide facility in Kwinana, just south of Perth, our capital. In addition to a number of other companies that are investigating lithium hydroxide production in the state. Beyond lithium, BHP Nickel West has produced Australia's first nickel sulfate crystals in Kwinana, again, just south of Perth. That was in September last year. Moving on to rare earths, Lynas commenced construction, again, of another Australian first, with its rare earths processing facility out in Kalgoorlie, to the east of Perth. And Iluka made a final investment decision to proceed with its rare earths processing facility in Iniaba, just north of Perth, having received $1.25 billion loan from the Australian government. And it's not just Iluka receiving government support. $1.6 billion of Australian government funding was committed to West Australian midstream critical mineral projects in the last financial year alone, across a range of debt as well as grant facilities. We have a $15 billion National Reconstruction Fund that was recently announced, and funding from that will be available for West Australian projects in this space. And this really is only the start. Further investment is in train, including battery-grade vanadium, and you'll hear from Ian's son in just a moment about one of their vanadium projects to the north of Perth. There's manganese, cobalt, graphite, as well as a few more. And perhaps most notably, the production of precursor cathode active materials, which is quite an important input into the manufacturing of rechargeable batteries. Continuing to support midstream developments and then looking further downstream is really the focus of the WA government at the moment. Can we move further downstream? Yes, I think maybe. And what we're currently doing to better understand these opportunities is we're undertaking a pre-feasibility study in consultation with industry and some of the research institutions in Australia to investigate things like cell manufacturing, battery assembly, and recycling. And early indications are there's a significant opportunity, a material opportunity, off the back of co-location, renewable, clean, cheap energy, and infrastructure that's designed for export. So that's a high-level overview of what's happening in Western Australia. Further information is available in our battery and critical mineral prospectus, which is available online in English, Japanese, and Korean. The prospectus gets into further detail around the advantages of investing in a place like Western Australia, whether that be low sovereign risk and stability of investment, a transition to a decarbonised electricity network. So we have a natural gas policy, and the West Australian government recently announced a commitment to turn off all state-owned gas-fired power generation by 2030. That's no doubt going to be replaced by renewables, as well as some of our research and development initiatives. So West Australia proudly hosts the Future Battery Industries Cooperative Research Centre, which is a $130 million collaboration between researchers, government and industry that aims to continue to improve global competitiveness in these industries. I've also included my contact information, and I invite you to reach out if you have any further questions. Thank you for your attention. Arigatou gozaimashita.
Thank you, Ben, for that great overview of critical minerals and future battery technology opportunities in Western Australia. Next up, we kindly welcome Mr. Ian Prentice, Managing Director, Technology Metals Australia. TMT is a WA-based company focused on developing its 100% owned Murchison Technology Metals project in Midwest Australia. The company is also pursuing downstream processing, value-add opportunities for vanadium electrolyte in Australia, the key material for vanadium redox flow batteries, which are expected to have a significant role in the emerging long-duration energy storage market. So over to you, Ian.
Many thanks, Nicole-san, and many thanks, Ben-san, for mentioning technology metals and our vanadium project and our aspirations around the development of our project. I would hope everyone can see my screen. So, technology metals, we are a vanadium mine developer. So we're developing a vanadium project here in Western Australia. So one of those fantastic critical minerals projects that Ben was talking about. And we've got a very clear focus on vanadium as being a key contributor into delivering a cleaner future for the globe as part of our transition to net zero. And we, as Nicole-san mentioned, we also have a very clear strategy around certainly midstream processing of our vanadium here in Australia. So Australia, like the rest of the world, is very much on this path towards clean energy and renewable energy, and we're, as Ben talked about, we're very well placed here in Western Australia for production of the raw materials for the batteries that are going to be required for that, and vanadium batteries are going to be a very significant component of that. Very interesting, the WA state government is moving towards dramatic reduction in thermal energy generation for our electricity grid in Western Australia. Renewable energies and other sources will be coming online to replace those, but the stationary storage, long duration battery storage is vital to making that happen. So Australia and Western Australia is going to be very much at the forefront of rolling out these large scale batteries to make sure that we have stability of our grids in a renewable energy environment. So vanadium redox flow batteries, that's the area that we're very much focused on, and we'll be providing key primary inputs to. They're very much in that space of the long duration energy storage, and you know, they're getting very much a global rollout of these very large scale batteries. As I say, as we're moving and transitioning from thermal energy through to renewable energy. So vanadium redox flow batteries have some unique characteristics that enable them to really, I guess, outperform and compete much better with some of the alternatives in this space. The safety is a really key consideration because it's a water-based electrolyte. There's no issues of fires and thermal runaways. Very, very long life, 20-year plus, multiple cycles through that life with no degradation. So the actual storage in these batteries remains stable through the life of the batteries. Over the life of the batteries, a very, very low cost of energy, and sustainability is one of the real keys in them as well. So the vanadium, which is the only chemical used in the electrolyte outside water and a bit of acid, the vanadium is pretty well 100% recyclable at the physical end of life of these batteries. So quite a unique solution for this long life, long duration storage of energy. So our goal is to be the first new vanadium producer in Australia, and looking at developing our Murchison Technology Metals project in the Midwest of Western Australia, which, as I say, is going to really drive this transition towards, I guess, net zero and reliance on renewable energy. So Australia in its entirety possesses 18% of the world's economic resources. We are, as we've talked about, a very politically and geographically stable jurisdiction, fantastic access to people. Our environmental standards are world class, so we're really well placed to develop these new projects to feed into this new environment that we're experiencing. And with the continued rollout of the vanadium redox batteries, we continue to
Ian, I think we've lost some sound. You've just kind of cut out.
How's that? Can you hear me?
Not very well.
Not very well. Okay. Apologies.
Is that any better? Have you got me now?
Oh, yes, that's much better. Thanks, Ian.
Okay, apologies for that. Technical issues. I think we're sort of completed on that slide. So very much vanadium is going to be key in our energy transition story. So we're developing, as I said, the Murchison Technology Metals project in the Midwest of Western Australia. A very large reserve. It's going to be a very long mine life, conventional processing with a large capacity production base for over 25 years. So we're going to be a very significant, stable producer and supplier of high purity vanadium into the vanadium redox flow battery market for a long time to come. Part of what we've been doing, and we talked about at the beginning in the midstream, is that we've partnered up with a Japanese company called LE System, and really looking at establishing that midstream, taking our vanadium, high purity vanadium, and moving that through into high purity vanadium electrolyte, very much to facilitate the rollout and establishment of the vanadium redox flow battery industry here in Australia. We're ideally placed for the generation of renewable energy, and now we're also very, very well placed to be able to supply the long duration storage that's required for that, and very much with our high purity vanadium, partnering up with a fantastic entity with LE System to really drive that process. So LE System already have a vanadium electrolyte operation in Japan, and we're looking to work with them to develop a very similar, if not slightly larger, system operation here in Western Australia. So really, it's all about that. Looking at working through the process now. We know we can produce the very high purity vanadium pentoxide and the product to go into the electrolyte. We're working through with LE Systems with their technical knowledge, their know-how to really develop up the footprint to develop our own domestic vanadium electrolyte production, and also partnering with LE System from an offtake point of view. So we can also provide our high purity vanadium back to Japan and to other jurisdictions around the world for LE System and others to also produce high purity vanadium electrolyte for these battery applications. As Ben-san mentioned, the West Australian government has been at the forefront of I guess, developing the battery, the critical mineral and battery industry, and been a big supporter of projects like ours. And we do have the Future Battery Industry CRC located here in Western Australia, and we're one of the key investors in a project with that research group, looking at optimizing the development of electrolyte and looking at ways to reduce the costs and therefore really increasing the applications for the vanadium redox flow batteries. So Technology Metals, we are poised to commence construction in 2023 on our Murchison Technology Metals project. We are very well funded. We've got a fantastic shareholder base. We've got a really good, strong board and executive team. And as I've mentioned, a very good quality support base through government agencies, the WA government, the federal government, a range of funding sources, groups like LE System, which are really, really vital for us in exploring that downstream and midstream and downstream opportunities within the vanadium redox flow battery industry. So we're very much focused on bringing our project through into production over the next few years, and then from there moving into the midstream development of our vanadium electrolyte So thank you very much for the opportunity to speak to you all today. My details are on there, and so please, if you have any queries, please reach out and have a chat. Thank you very much.
Thank you very much, Ian. Vanadium is certainly a commodity that's gaining more and more attention with the rise in urgency to secure battery supply chains. So thanks very much for that presentation. Now we have Mr. Matthew Lawson, Chief Financial Officer and Director of Sunshine Hydro. Sunshine Hydro is an Australian company focused on providing firm green energy. Their technology is used to model, manage, and orchestrate highly efficient and cost-effective superhybrid renewable projects. Over to you, Matthew.
Thank you, Nicole-san, and good afternoon, everyone. I'm Matt Lawson, CFO and Director of Sunshine Hydro. I'm presenting today with one of our amazing team, Lisa Ollard. She's going to help me out. We'd love to welcome all the potential Japanese investor groups, and we thank you for your time today. Also, just want to thank Takara-san and the TIQ team for all your ongoing support. We're really excited today at Sunshine Hydro about the recent support announced by the Queensland Government to our sector. This commitment will accelerate the momentum of green energy businesses like Sunshine Hydro, so it's just fantastic news. Look, we've got a lot to get through in 10 minutes. I just firstly like to say that that we at Sunshine Hydro, we're genuinely excited about the opportunity to partner with Japanese investors and also partner with Japanese businesses to expand our business and support our projects. So the next slide is just in relation to people. Actually, Lisa, did you want to just pay respect to the traditional owners?
Yes, thank you, Matt. Ladies and gentlemen, thank you so much for having us here today. So yeah, we at Sunshine Hydro acknowledges the Australian, Aboriginal, and Torres Strait Islander peoples of this nation. We also recognize their custodianship of the land, and we seek to always include them in our decision-making in a way that will bring employment and give them agency in development. We also pay our respects to ancestors and elders past and present. Thank you.
Thank you, Lisa. I won't talk about myself. The only thing I will say is that I have enjoyed over a couple of decades doing business in Japan and built many lasting partnerships and business partnership and friendships, and also work with TIQ to do some exciting things mainly in Tokyo. In terms of our board, if we had more time, I'd probably talk more about them, but we have an amazing board at Sunshine Hydro. There's over 200 years of experience. Michael Meyer has been a 40-year green energy advocate and done amazing things with the Meyer family in this country. Rick's an amazing leader and CEO. Chris is the founder and the brains behind a lot of the IP in our business around our software and the concept of our project model. Simon is the principal and founder of Energy Estate. You've probably heard of Energy Estate. They've been a leader and pioneer in the transformation of global green energy in the global green energy sector. So we're very lucky to have Simon as well. In terms of our business model, we might just, over to you, Lisa, we might just play a short video.
Yes, thank you. So this is our corporate video featuring our chairman, Mr. Michael Meyer, representing what our vision is, that is to decarbonize the world.
What gets me up each day? The fact that the biggest revolution since the Industrial Revolution has begun. The green energy and green hydrogen revolution. At Sunshine Hydro, we are very proud to be at the very forefront of this revolution. The multi-trillion-dollar scale of this revolution will easily eclipse the scale of the global oil, gas, and coal industry. We started our journey in 2016. with the mission to help decarbonize the planet. Our solution is what we call a super hybrid. This combines 100% renewable energy, wind and solar, with pumped hydro, together with electrolysis and liquefaction. Each of our super hybrids will transform renewable energy into firm green energy and green hydrogen at scale. All made possible by our unique proprietary software, ESOP. ESOP has been developed to factor in dynamic variables like weather forecasts, electricity demand and prices, reservoir water levels and hydrogen production, among many others, to optimize the performance and profit of a super hybrid. So what happens when the sun goes down? When the wind isn't blowing? These are the questions that have prevented renewable energy from dominating the global oil, gas, and coal industries. Until now. With a super hybrid's powerful software and deep energy storage, we can keep the lights on 24/7, 365 days of the year, in all weather conditions. It's the solution that serves communities, stakeholders, future generations, and the planet alike. Energy costs will fall, jobs will be saved and created, regional areas will be invigorated, ecosystems will be protected, and biodiversity enhanced. New industries that we can't yet comprehend will be built upon the foundations of 24/7 firm green energy. Green steel, green cement, and green aluminium all will become reality. And the best part is that all of this growth does not come at the cost of our most precious asset, and that's the planet. We'd like you to join us in keeping the lights on now so that we can keep the lights on for generations to come.
Thank you, Lisa. As mentioned by our chairman, very passionate man in the video, Sunshine Hydro has a uniquely clever and diversified business model. The business generates revenue from two specific but connected business divisions. The first one, as Michael mentioned in the video, is through our ESOP software license fee sales. ESOP stands for Advanced Energy Storage Optimization Program. And Sunshine Hydro will license this software to both external greenfield and brownfield project operators across the planet, as well as also license the software to our internal Sunshine Hydro greenfield super hybrid projects. Sunshine Hydro will also receive a recurrent revenue stream by the charging of a green energy input fee for projects using our software. The second major revenue stream, so the business has two parts. It is a software developer and then utilizes that software for external projects and clients, and then also utilizes the software on our internal projects. So the second major revenue stream relates to our own projects, and this is from the development fee revenue following the sale of our super hybrid projects that are delivered by our company through early stage development to financial close. So Sunshine Hydro, we're early stage developers of super hybrid projects and not necessarily the ongoing owner and operator. We'll explain shortly the concept around ESOP further and the super hybrid. So this is just a diagram that shows the super hybrid model. Many traditional pumped hydro projects are not financially viable without government incentives and support. Our super hybrid solution adds green energy wind and solar inputs with the upper and lower reservoir with pumping and generation equipment, together with electrolyzer, creating hydrogen storage and liquefaction. And the key to all of this is our ESOP software, which monitors 30 different algorithms, making decisions around optimization of operational and financial project performance. The next slide just shows some further detail around super hybrid revenue streams, showing that the various revenue streams from our super hybrid project. The grey pie pieces represents only the revenue generated by a typical pumped hydro project. The yellow is revenue only available to a deep storage super hybrid project. Our modelling indicates that these revenue streams expand project revenue by up to 50%. And the green pie pieces also show gaseous and liquid hydrogen revenue. So if we could talk about our projects, Lisa, if you wanted to just refer to this slide.
Thank you, Matt. All right, so what you can see here is our first super hybrid project. This is located in the Gladstone area, and we call it the Jandori-Gung-E Super Hybrid Project. So this is going to be a 600 megawatt super hybrid pump hydro, and it's going to produce 220 megawatts base load of firm green energy. So recently we had a lot of news published about this project in the Gladstone area. This is just one of the projects that we have identified across Australia.
Thank you, Lisa. Yeah, that's a conceptual video of our Jandori project, and we have a portfolio of 10 super hybrid projects at the moment at various stages of development. If we just move to the next slide, with more time, we'd love to go into a bit more detail around our ESOP software, but the software contains more than 30 different algorithms, all making decisions, as I said, around optimization of operational and financial performance relating to a super hybrid project. We'd love to talk more if you want some more information, because it's quite technical. We can do that on another occasion. If we move to the next slide, Lisa. Lisa's just going to show a bit of a live simulation of the software.
Yes, so this is the live simulation for our Jandori project. So this is using our ESOP software. As you can see, it has all the components that Matt has discussed. We have supplies from wind, from solar. We have our upper and lower reservoir here, our electrolyzers. We have our grid. But what we are very particular of is our base load. We strive to maintain the 220 megawatts firm green energy base load on here. So on this one, we also have the data being collected by our software. Every 5 minutes, the data may change. So it captures different algorithms using this one. It provides us information about the supply and demand and our gross profit as well. So as you can see here, it could provide us our gross profit for a day, for 3 days, for 7 days, or for 1 month. This is the simulation of our ESOP software. And if you want more information about this, we actually have our investors meeting always conducted by our Chief Executive Officer, discussing or giving more in-depth information about this.
Thank you, Lisa. And what I love about this software is it's my job to financially model these projects, which is very complex. And this software produces GP simulated performance and can essentially set up a digital twin for a project, which is really clever. Just to finish off, we have two investment opportunities in the market at the moment. The first is our A round capital raise of 65 million Australian at a share price of 210. There's a use of funds table there that the funding will be used largely across 3 different allocations. One is to expand our software team and to progress the commercialization and sale of our software product. It's important we are aiming to have 100 sites globally. So there's allocation towards site identification and land acquisition. And the third allocation is to progress the portfolio of 10 projects to early stage development. So that's the first investment opportunity. The second opportunity that we have currently is an immediate term opportunity, which is a convertible note. We do have interest, some strong interest in the A round. We have a convertible note in the market, a minimum of 100,000. The term is 12 months. The terms are very good. The coupon rate is 8%. If it is cancelled or paid out, there's an additional 15% if it's paid out within the 12 months. And on conversion, after the 12-month term, the share price is $147 Australian. So we just want to give you a bit of an understanding. Obviously, there's a lot more to discuss there, but just an understanding of investment opportunities in our business. Lisa and I thank you for your time today. We look forward to the potential opportunity to partner with a Japanese investor or group of investors, and also supporting and forming partnerships with other Japanese businesses. Thank you very much.
Thank you, Matthew. A real fascinating example of the use of new software technology to manage the complex nature of renewable energy projects. Our next speaker is Mr. Christiaan Jordaan, CEO and founder of Sicona Battery Technologies. Sicona develops next generation battery technologies used in anodes of lithium-ion batteries that enable electric mobility and storage of renewable energy, as well as commercializing an innovative silicon composite battery anode technology. Over to you, Christiaan.
Thank you. Good afternoon, everyone. It's a great pleasure to be presenting Sicona today. My name is Christiaan Jordaan. I'm the CEO and founder of Sicona Battery Technologies. And Sicona, by way of background, is a battery materials technology and manufacturing company based here in Australia with headquarters in Wollongong, New South Wales. Our purpose and mission is to use our innovative battery materials in existing liquid electrolyte lithium-ion batteries to increase the range of electric vehicles, reduce the time it takes to charge these vehicles, and also help reduce the upfront cost of the vehicles. Whilst we also have a very strong focus on delivering sustainable, localized supply chains of battery materials, starting with the commercialization of our silicon anode materials into the market as quickly as possible. So just a further background, the company was established in 2019 with last funding round was last year, July, where we raised $3.3 million in a pre-Series A safe note round. We're currently busy concluding a $25 million Series A funding round. We have 13 full-time employees, 44 pending patents, and 8 patent families. And as I mentioned, we're headquartered in Wollongong, New South Wales, which some of you may know recently hosted the UCI World Championship cycling event, which was a major event watched by more than 300 million people around the world. Just some highlights on Sicona. Since we acquired our technology that came out of the University of Wollongong laboratories, we then took that technology and have designed and built a 2.5 ton per annum pilot manufacturing plant for silicon composite anode materials. And we've done that with the help of some co-funding from the Australian federal government. We've advanced our patents and have some recent patents granted in Australia, acquired additional patents and lodged additional patent families. And we've also been quite active in engaging with a handful of automotive and automotive-focused cell manufacturers from around the world to qualify our materials and gain interest. And we're just starting the process now of qualification and sampling with a number of cornerstone customers. What's more, we've also done a lot of work on the next stage of development, which is commercial production, and we're working very closely with Bechtel, one of the largest engineering construction companies in the world. Over the next 12 months, we will also be working closely with one of our automotive customers in the US in a development program for high energy density lithium-ion batteries using Sicona silicon anode battery materials. Sicona is a participant in the existing lithium battery supply chain, which is estimated by Morgan Stanley to be worth almost $500 billion a year by 2040. The biggest value within that supply chain is shown to be the battery materials segment. where Sicona's core product and major focus at the moment is next generation silicon anode materials, but we also have further products in development in cathode materials, electrolytes, and binders. Our customers, as I mentioned, are some of the companies illustrated on this slide, cell manufacturers around the world, both established and new ones, as well as automotive companies that are focusing on the production of electric vehicles. Just a very brief overview on the operation of a lithium-ion battery 101, if you will, but just highlighting the use of silicon, which is on the anode or negative electrode of a lithium battery. Dropping that material into your anode material can increase energy density through enabling more storage of lithium ions in the battery. However, silicon is well known to pose a lot of side effects and negative side effects on the operation of a battery. So it is required that you do nanoscale engineering and manipulation of these silicon materials. And more importantly as well, is that you have a solution which is scalable and cost effective. And that's exactly what Sicona and our inventor team have discovered and are commercializing. This is quite a large market opportunity. We estimate by 2030, approximately $15 billion per annum. Most likely that is underestimating the potential for silicon anodes, which is now becoming extremely important for all the major cell manufacturers and automotive companies as they are seeking to reduce the dollar per kilowatt hour cost of their battery cells and their battery packs. And silicon anodes enables that to be achieved. So we have an aspiration to localize our supply chains and to build commercial scale manufacturing in the United States, Europe, and in Asia outside of China. We plan to start our first commercial scale production facility in the United States, where we have a number of foundational customers that will be buying the materials. And we're getting, we believe, a lot of support locally from the United States government. So that is a major market and focus for us at the moment. A little bit of a brief overview of our development timeline for our silicon anodes. We're currently operating our pilot manufacturing plant and so starting to supply larger samples to our customers, entering and kicking off with our first joint development agreement with a US automotive company. And then concurrently with all of that, we're doing engineering work, including the selection of an appropriate site in the United States. That is already underway. And then we plan to have all of that work completed and start construction of our first commercial plant by the end of next year, with a fast track into commercial production by the end of 2024 or start of 2025. We currently have a really phenomenal asset in New South Wales, which is our pilot manufacturing plant and our cell prototyping lab, where we have a dedicated team of engineers and battery scientists working away at producing our silicon composite anode material. As I mentioned before, we have been engaging with a number of blue chip customers in the automotive sector, as well as in cell manufacturing from across the world. And we are shortly ramping up that activity and actually have, I would say, more demand from customers than we are immediately able to service with sampling. Our core team are made up of dedicated, very experienced chemical engineers, battery and nanomaterial scientists, and researchers, as well as my background, which is on the commercial side, and a background in the supply chain, specifically in graphite, and in Africa, where I discovered a graphite deposit and developed a project there. Some of our partners illustrated on this slide, where we've already started engaging, not all of them on this slide, with a number of partner groups, both equipment suppliers and partners on the supply chain and battery cell testing side in Japan. So we are already starting engagements with the Japanese industry, and then very proudly supported by the Australian federal government and major venture capital investors in Australia and the United States. So thank you very much. That was a very brief overview of Sicona and our business. Please get in touch with me should you require any further information or be interested to discuss our battery materials and our plans for the future. Thank you.
Thank you, Christiaan. A really innovative presentation on technology in the battery development space. Over to our next speaker, Mr. Dawson Johns, CEO of Zenaji Australia. Zenaji is an Australian company specializing in the research and development of battery storage systems. Zenaji have created both small and large-scale battery solutions using lithium titanate chemistry. Over to you, Dawson.
Thank you, Nicole-san. Excuse me. I'm sorry I can't show you my not so handsome face. The camera on my screen is not working. Let me bring up a slideshow. Zenaji, we started, Zenaji is a company full of engineers predominantly, started life looking at what is the best battery solution right now for long-term storage of energy, and where should it be placed? And we asked a lot of questions about energy storage, and ultimately decided that batteries that were made for mobile use, phones, computers, etc., were not the correct solution or not the right solution for long-term storage in homes, grid scale storage, and everything in between that was stationary, mainly because the lifespan of those batteries simply didn't match the lifespan required for long-term storage, and the cost per kilowatt hour was too high for most people to stomach. So in our search, we came across Titanate Batteries, which interestingly enough had originated from Japan through Toshiba. But they hadn't proliferated, predominantly because the cost of batteries was roughly 10 times the cost of a LiPo-style battery. So we hunted around to see what the current cost was, came across a number of manufacturers, mainly in China, and found that the cost had gone to about 20% of what Toshiba had originally charged for the batteries. So it made them a viable solution. The problem then was to develop actual scalable solutions, and we began that process of engineering actual solutions, battery management systems, battery protection systems for batteries. And so this world problem, we started to look at this as a world problem and how would we solve it. And the issues around that, we looked at every single one of them that we thought was critical, and LTO and our solution solved the problem. And then we patented how we charged the batteries. So these were the storage problems that we looked at, in particular safety, longevity, cycle life of a battery, all of those things that really preclude current batteries from large-scale storage. And interestingly enough, although they are being built into large-scale storage, we've got 100 megawatt type solutions right now in Australia. I'm not sure what's in Japan, but these are being built around the world using exactly the same cells that are in your phone. And it really doesn't take a science degree if you ask yourself, how many times can you use your phone and charge your phone every day before the battery gives up? Because exactly the same thing happens in large-scale batteries. So one of the biggest issues, and I think, and Ian certainly touched on it with batteries, and particularly large-scale batteries, is thermal runaway, where you get spontaneous combustion. Lithium titanate does not suffer from that. So they are a much, much safer solution than LFP or NMC technology batteries. They simply don't have that flammable spontaneous combustion that you see in current batteries. So we have this mission to deliver a premium battery storage solution cost effectively that will last a lifetime. And by a lifetime, if you only cycle it once a day, we're talking 30, 40, 50 years, possibly more. So our solution is twofold. We have, at the top there, you can see what looks like a Toblerone chocolate bar, only about 1.5 meters tall. That is a 2 kilowatt solution that can be put in parallel, as you see lots of them in parallel on the top there. And you can build up 20, 30 kilowatts of battery that way. And it's still a 48-volt battery, so very safe. And it will last, well, if you're only cycling it once a day, we'd expect it to last 50 years. If you cycle it 3 to 5 times a day, it will last somewhere around 30 years. And we have a 20-year warranty on it. So we guarantee that it will last 20 years and be above 80% at the end of 20 years, i.e. the batteries will have more than 80% capacity at the end of 20 years. We also have now containerized solutions, as you can see there. And that's made up of, I'm going to skip through this a little bit because we are short of time. That's made up of, I'm going to run through it, these batteries, which are our Eternity battery. That is a 32 kilowatt stack there, roughly 2 meters high, weighs about 700 kilos. And very large scale batteries are made up of lots of these. So you can put them in series and have voltages of up to 1300 volts, or you can have a single one of these at 48 volts. So they cover the market from grid scale through to corporates down even to very large homes. I have one going into my own home very shortly. Right, I'm going back. Sorry, I'm going back and forth a little bit. So what does it give us? What do these batteries really give us? Well, they give us 22,000 cycles. They give us 100% depth of discharge. They are available in a multiplicity of options depending on the client need. They can work in practically any temperature. They work up to 65 degrees and down to -40 degrees. So if you wanted to put one at the top of Mount Fuji, you could, or if you have places where it gets very hot during the summer months, these batteries do not need air conditioning. They do need airflow, but they don't need air conditioning, which makes them, again, very efficient. They are designed, as I said, for long duration storage and a very high cycle life. We have one of these cells in our own office that is being charged 12 times a day. So it's fully charged and fully discharged 12 times a day. And it has been going now for over 2 years. And it's degraded about 8%, I think, over those 2 years. But we are absolutely thrashing it. If you did that to any other lithium battery, you would kill it. It would be stone dead. So there are differentiators. We don't, again, if I can just run through them quickly, the battery chemistry does not suffer from thermal runaway. It is far superior to LiPos or LFP or NMC technologies. We provide the longest warranty on the market currently. We provide the lowest cost per kilowatt hour. However, the batteries do have a downside, and that is they use twice the materials of a standard lithium battery, which makes them twice as heavy. Now, the cost per kilowatt hour stored and retrieved over the life of the battery is approximately 7 cents. If you compare that with, let's say, a Tesla, and I'm only taking them as one, not as one user of LFP technologies, their cost per kilowatt hour comes out at around 30 cents per kilowatt hour to store and retrieve energy over the life of the battery. So they're really chalk and cheese in terms of the long-term viability of the batteries. However, ours will be roughly twice the cost up front. So the upfront cost is high, but the long-term cost of storage is vastly reduced. Another advantage of LTO is that they can be extremely rapidly charged and discharged. You can, in fact, charge an LTO battery from stone flat. You can fully charge it in 6 minutes. Hence the reason they are being used in buses, trains now in Germany, and other heavy vehicles where they really excel. But they do have a weight disadvantage. So for normal cars and for other mobile applications, they may well not be an appropriate solution. They do provide better temperature tolerance. The battery will last at least 5 times longer than other lithium batteries. And clearly the research is going on to improve that life expectancy. There's a very quick summary of our AON battery. And there's a summary of our Eternity battery. And we do have another battery coming out. In fact, we have 2 other batteries coming out next year, which will be larger batteries for middle of the road use. And some of the inverters these days actually want to start at a higher voltage, charge voltage. So we're going to bring out a battery to suit those inverters. So that's who we are. That's what we do. We are a leader in the field. We have markets now developing around the world. We will enter the North American market next year. We are currently in the European market. Obviously, we're in the Australian market. I do not have a distributor in Japan, and I would dearly love to have one. So if any of you are interested in our technology, we would love to talk to you. We are also doing a capital raise. This time it's for $5 million, and I'm happy to talk to anybody who's interested in that. So thank you for your time. I really do appreciate it. And Cole, thank you.
Thanks, Dawson. Your business really meets the current needs of creating safer and cost-effective battery storage solution. Thank you for that. We have our next speaker, Leigh Whicker, Commercial Manager of Entex Limited. Entex was founded in 2014 by a group of mining, energy and manufacturing innovators who were driven by the desire to make energy and industry cleaner. Their disruptive approach is to form incubator laboratories. The first is in Adelaide that will generate breakthrough ideas. This will come from areas such as carbon capture and utilization, non-mining uranium recovery from phosphate fertilizer, and green and blue hydrogen. Can I just quickly remind everybody to be on mute? Thank you very much.
Good afternoon. Thank you very much, Nicole. Thank you very much for the opportunity to present today. As you mentioned, Entex is a South Australian company. It's Clean Energy Technologies. And when we're talking about clean energy technologies, we're not talking about wind or solar. We're talking about innovative technologies that we bring from concept through to commercialization. And we've also got a couple of clean energy projects, which we'll deal with in a minute. So, as I said, we take clean energy technologies from incubation to commercialization. So that's really transitioning technologies along that technology readiness level stage, going towards commercialization. We operate in a number of different areas, including uranium, hydrogen, green hydrogen, and power generation technologies using radioactive materials and waste radiant heat, and also some carbon conversion technology, which is quite early in the piece. So in terms of some of the key sectors and applications, as I said, nuclear fuels, really industrial carbonisation, hydrogen, space, defence, and the Internet of Things. We raised about $6.5 million in July of 2021, and since then we've had grant funding of nearly $3 million just this year. The way we go about our business in developing these technologies is probably best described using what we call our circle of life. So we're looking at doing the inventing and incubating these ideas and these concepts through that technology readiness level, and then deploying and launching that capability. So in the first stages would be identifying clean energy concept technology. What we do then is we bring that through our technology incubator, where we do some of that technical and commercial evaluation up front. Successful evaluation usually results in a patent for that particular technology. We then create industry and academic partnerships. We've got very good relationships with both researchers and industry in this space. We'll develop the technologies through research and development programs, develop manufacturing processes, produce demonstrators and early prototypes, and these will then be refined and deliver the prototypes for evaluation, whether or not that be ourselves or to a customer. We'll look at scaling the manufacturing, and then we'll commercialization or monetization event. So monetization event I've got here is M&A, but that could just be a spin out in its own separate entity that we operate, or potentially a sale event around that. We operate the business in 3 pillars. We've got the technology incubator, which is some of that early stage technologies. Smart semiconductor structures, which we'll focus on a bit more today, and some of the zero carbon fuels. And with all of this information is available offline if people see interest in some of these adjacent technologies to the smart semiconductor structures. We've got a team of people that are quite diverse, technical and commercial people, mainly from the uranium mining and rare earths mining sector, radiation and materials specialists and scientists, radiation regulatory. We've also got people from automotive research and design, and also from the resources and oil and gas sector. So we'll focus on the smart semiconductors pillar at the moment. So we've got two innovative technologies in there, being GenX, which is a beta voltaic power generation device or battery. And we've also got Gen-T, which is turning waste industrial heat into power. So that particular pillar is run by Dr. Scott Edwards and Jake Whittenbury, who are both from automotive manufacturing and research development. Looking at the GenX beta voltaic power generation unit, or what we're calling a battery, essentially it is a smart semiconductor, not too dissimilar to a photovoltaic device, but instead of utilizing the interactions of photons with a semiconductor, it's actually internalizing that energy source and using the energy from beta decay, which is the material incorporated into that semiconductor structure. So we're not relying upon the sun, and effectively the battery can operate under various challenging environments and conditions. So we've patented this particular technology. So it's really a novel semiconductor metal electrode. We're combining that with a beta radiation, and it's producing essentially decades-long power, uninterrupted and safely, depending on what the isotope we're using. So where this is a game changer when you're considering power management strategies for various applications, we're able to replace solar panels. So when you're thinking in a space environment where the further you get away from the sun, the efficiency of solar power generation decreases markedly. And when you're looking at dark side of the moon applications, when you're looking to effectively trickle charge lithium batteries or use it as a smaller primary power supply. So in terms of energy density, watts per kilogram, we're very similar to conventional batteries. We're looking at some isotopes that are effectively over 200 watts per kilogram, depending on what the application is. So we're really focusing for this particular technology on the global space power market. That's looking to grow to sort of $5 billion by 2026. We're currently working with a couple of global aerospace primes. One is looking at potential applications on a lunar terrain vehicle program, and we're also negotiating access to the International Space Station at the appropriate time. Once we've got a space qualified prototype, then there is the ability to get flight qualification on the ISS at some point. We're also working with defence and some Earth observations, remote monitoring market. We're really developing this through a grant-funded project at the moment. So we've got a strategic partnership with a cooperative research centre project, we've received $2.4 million funding, which is going towards a $6 million project, working with academic partners, University of SA, Uni of Adelaide, and Uni of Western Australia, also in industry partners being Durama and Ascension. We've got MOUs with companies like Fleet Space, Space Machines Company, and the University of Adelaide. Moving on to our Gen-T waste industrial heat to energy. It's very similar semiconductor structure to that of Gen-X, and essentially getting developed by the same program, and then that will peel off into its own project in itself. But essentially, instead of using beta radiation to excite and generate electron hole pairs within that semiconductor structure, we're doing that via waste radiant industrial heat. So this particular project is partially funded by an innovative manufacturing CRC with the University of South Australia. And what we're going to be developing here is essentially a flexible sheet, for want of a better term, that will have that semiconductor structure be able to be formed to various energy or heat emitting assets within, steel manufacturing or cement manufacturing, and capture that waste heat, turn that into electricity, and essentially increasing the energy efficiency of that heavy industrial user. So our strategic objectives for the business is really to, by 2026, commercialise a minimum of 3 revenue-generating technologies. Essentially, they're probably going to be Gen X and Gen T will be part of those. We're looking at currently developing a manufacturing process which will be housed in a manufacturing facility, which we're looking to have built by the end of 2024, and that will house the scaled manufacturing line for that. So just to round out this short presentation, again, thank you very much for giving me the opportunity to present. Our contact details, Bryn Jones, the Managing Director, and myself as the Commercial Manager. So very much welcome to the interest from potential Japanese partners.
Thank you, Leigh. A really fascinating technology with uses across multiple industries. At this point, we will welcome back Mr. Masaki Takahara, Managing Director of JETRO Sydney office. Over to you, Takahara-san.
Nico-san, thank you very much. Let me share my screen. My name is Masaki Takahara, a Managing Director of JETRO Sydney. Thank you for joining us today. Let me just talk about the post-event survey. When you exit Zoom, a post-event survey will pop up. If you would like to have business meetings with any of the 5 companies, please select that option in the second page of the survey form, and we will arrange meetings under JETRO's Jaybridge program. Also, if you have any comments on the webinar, please feel free to write. Your feedback is highly appreciated. In case the survey form doesn't appear properly, we will send you the URL for the survey later, along with the URL for downloading today's speaker's presentation slides. So please use that as well. Now let me introduce Jaybridge program briefly. Jaybridge is a business platform to facilitate collaboration or alliances between Japanese companies and innovative Australian companies to develop the business overseas. JETRO supports cross-border open innovation for accelerating digital transformation. This spans across 6 sectors: carbon neutral, mobility, retail, healthcare, agri-tech, and smart cities. Specifically, we will provide Jaybridge member companies of Japan with information on promising overseas companies, support for business meetings with the companies, and support for strategy formulation and business development through experts. If you are interested in this service, please contact with JETRO. Thank you. Over to Nico-san.
Thank you, Takahara-san. And to provide the closing remarks on this afternoon's webinar, I'm very pleased to welcome Mr. Naoki Semio, Acting Consul General of the Consulate General of Japan in Perth.
Yeah, Semio-san is now speaking in Japanese. So if you prefer to hearing English, please choose English channel. Thank you.
はい、ただいまご紹介に預かりましたパース総領事官の千明と申します。本日、Nichi-Go Global Jaybridge のコラボレーションウェブナーにご参加いただいた皆様に感謝申し上げます。5つの州から参加していただいたテクノロジーメタルズオーストラリア、サンシャインハイドロ、シコナバッテリーテクノロジーズ、ゼナジー、エンテックスの企業の皆様、素晴らしいプレゼンテーションをありがとうございました。4回目となる本日のウェブナーは、豪州におけるクリーンエネルギー、電池分野の新たなビジネス機会がテーマでした。我が国は2050年カーボンニュートラルを目指すことを宣言し、温暖化への対応を成長の機会と捉える時代に突入しております。 本日のプレゼン内容であるグリーンエナジーやバッテリーテクノロジーはカーボンニュートラル実現の鍵となる技術の一つであります。新しい時代をリードしていくチャンスの中で、今回のウェブナーをきっかけに、日本とオーストラリアとの新しい協力関係や具体的な投資、イノベーションを起こすといった前向きな挑戦につながることを期待しております。最後になりますが、今回のウェブナーを主催したNichi-Go州政府、他の4つの州政府の皆様、そしてJaybridgeの取り組みで協力いただいているJETRO、またこの取り組みを支援していただいている AJBCC とイノベーション道場にも感謝申し上げます。このウェブナーシリーズがさらなる発展を遂げていくことを期待しております。本日はどうもありがとうございました。
セミオさん、ありがとうございました。On behalf of Invest and Trade Western Australia, I'd like to thank everyone who registered and participated in this webinar today. Our WA government offices in Tokyo, Kobe, and Perth, and in other key markets welcome your contact to continue any discussions on opportunities. Please do reach out to us. We've had a lot of presentations today and we've learned a lot, so thank you so much for joining us. And if you do have follow-up questions, please do contact JETRO. お疲れ様でした。よろしくお願いします。Thank you.